Okay. Hi, everyone. Thanks for taking a part of your lunchtime to listening to my quickie about onions. Not the vegetable, but the architecture, and especially also a deeper loop into stereotypes, what we can achieve with stereotypes. I would like to do this talk especially because here at Vox Days we have a lot of technical talks focused on Kafka, on databases, on new Java frameworks, new programming languages, etc. And we are really living in a time where technology is evolving such quickly. I mean, you can do your Angular 2 project and 6 months later, 3 or even 4 is starting to come on the market. You could say, yeah, let's do now a GraphQL API instead of a REST API. And then you see, oh, but there is now this protobuffer stuff from Google. So actually everything you do when you start to do it, once you are done, it's almost old already. And developers, in general, passionate developers always want to use the new things. And on the other side, we have the business. And the business, I don't want to say that business looks like a slug. That's really not what I want to say here. But business is slower. And if you take any business, let's say we take insurance. An insurance is insuring cars. And a car is a car. And the model for insuring a car is almost the same. I mean, what they changed in the last 20 years is maybe they added a little crash recorder so you could have to pay a little less for the insurance. But basically we still just insure a car. The same is for banking. If you buy stocks, yeah, you buy stocks. It doesn't matter if you buy ABB stocks or UBS. And even when new features are coming, like cryptocurrencies now, it's a totally new product. The business itself, stock trading, is not changing, okay? And what I want to show you today is how you can build an architecture where the business is kind of sealed and protected against technological changes, so that you have to define once what your product is doing, what's important for the business, and then you have the freedom to change the technologies at the pace you want. And to introduce that, I would really have a short look, only 3 slides about the 3-tier architecture. I'm curious, who uses this architecture in his daily job? Yeah, quite a lot. I mean, I would say that's an established architecture where we have well-defined layers. We have a presentation layer. The presentation layer displays information. If you have more an application with some SPAs, then you would typically have some REST services, or if it's a little bit older, then you would have server-side rendering, or you already use the new trends, again, server-side rendering. Then we have the application tier, and the application tier is more or less the layer where you would put the business logic, your domain model. You would integrate technologies. Ideally, if you have to listen to a JMS queue, if you have to communicate over SOAP with other services, this would typically be done on this layer. And it's more or less an orchestration work. Like you are getting data from the data layer, maybe you take 2 different objects, you mix them a little bit, give them back to the presentation layer, and the presentation layer is returning it. And that's for me the biggest issue in this model. I will come back to that. And the last layer is the data tier, and it contains the data access objects. And if you read on Wikipedia the definition of the 3-tier architecture, it's explicitly stated that in this layer you shouldn't have any domain logic. Okay, so it's really just objects that contain data, no domain logic at all. And for me, the biggest problem is that in the application layer is the layer that becomes really huge. And in the end, it's the layer that contains the whole business logic. But it's not well structured because you have your services and it's more an orchestration layer that gets data, merges them, maybe do some transformation and returns it. And if you have a look to other architectures, for example, the domain-driven design, which is, in my opinion, a perfect fit for an onion architecture, Domain-driven design does exactly the opposite. They say you have a domain model where the whole business logic is encapsulated inside your model and completely independent from technologies. And to do that, the idea is to have a domain. So you really have pure Java classes. Usually when I do a project with an onion architecture, in the domain I have no frameworks at all. It's just the JDK. And my goal is to implement all the needed features, really all of them, just in this domain. So it's much easier to test, of course, because you have no external dependencies. And especially you can see exactly in your code what the business is. You have really a clean code that expresses the business. And then you have an API layer, and it's not an API in the sense of REST API layer, but it's a layer of classes that provides an API to interact with your domain. Okay, so from the outside, from the infrastructure layer, you would call these classes to communicate with your domain. And what's special, and that's why they say it's an inversion of dependencies, the dependencies come from the outside to the center, and that's the way we can protect the domain. So the domain has dependencies on no layer from the outside. So from the developer is not even able to, for example, access a REST controller from the domain layer. And that's really, really the key. Ideally, if you work with Maven or any other packaging tool, you can make sure that it's separated on a class path level. So you are sure that no developer is ever going to access some infrastructure service out of the domain layer. And what's really hard is to do this mindset switch and work in the domain with pure Java. And I did some experimentation with projects and new developers, and I told them, just do it by ignoring everything. You ignore the database, you ignore if it's SOAP, you ignore if it's asynchronous. You write your domain model so that it works in the JVM. And I would like to be able to run every business case we have to cover on the API layer from the domain. I don't want to have a dependency on anything. And I had interesting discussions because we are so used to think about, oh, but the database, oh, but this is going to be asynchronous, etc. And I always told them, no, ignore it. And this is a problem we will have to deal with in the infrastructure layer. It's not the problem of the domain, because the domain is a representation of the business. It's not a representation about technologies. And as an example, if you would have your classical application tier, and we would read, we have a chat service, and we have to mark a chat message as read. What we would typically do is use some repository, get this message out of the database, set the read flag to true, and then maybe we would have a push notification service to notify the other devices that the message was read. And that's a business operation in the sense that the business would tell you, hey, I would like that the people chatting are seeing when a message is read or not. That's a business requirement. But here we are mixing already with push notification, the message repository, and especially this business logic is not part of the chat message. It's extracted into an application service. The DDD way would add a method with semantic, mark chat message as read, on the chat message itself, and would encapsulate the business logic in there. And you can see that in the mark as read method, in the chat message aggregate, we are using a notification service without any assumption how the other devices or other users are going to be notified. We just say, we notify the other users. But if it's a push notification, some WebSocket, some whatever message bus you want to use, that's not relevant from a business perspective, right? Just need to know that here. The same is for the repositories. In your domain, of course, you have the requirement that when something is created, then it has to be persistent and it's not deleted at any time. But the way it's persisted is not relevant again. So what you would do in your domain is have a message repository interface. There you define all the methods you need to work on your domain model. So you would typically have a save, find, get, and so on. But if it's implemented using a text file or some document-based database, that's not relevant again. And even if you know it's SQL, it could be JPA, it could be JOC, it could be whatever framework you want. And here you already see a little bit where it's going. If in your domain you have just the interface and you express what you need from the repository layer, but you're not actually binding it to some technologies, and you want to do a switch, for example, from JPA to pure JDBC, then you would have to do that only in the infrastructure layer, and you wouldn't break any business rule because the business is in the domain and you won't touch the domain if you have just to change the technologies. And here again, I did an experiment because developers are very resistant or reluctant to do that because it means more work. And this work pays off if you have to maintain the app for 10 years because you are sure that the domain is stable. And they asked me, but could we at least use JPA in the domain, the annotation, because it's really annoying to do this mapping outside? And I told them, okay, then if you want, try it out. They did it, and then a few months later, they came to me and told me, but with DDD, actually, it would be much better to use a document-based store because then we could save whole aggregates at once as a document in MongoDB, for example. And we said, okay, then let's do this switch. It's just a technological switch. But they had to actually change the whole domain because they used this JPA so intensively in the domain itself. And that's why I really try to have no dependencies at all in the domain. Then there are cross-cutting concerns like transactions, services, etc. And there we use stereotypes. So usually an application service, which are the services on the API layer, is annotated with an annotation, application service in this case. And this annotation is, again, not something coming from the outside. It's an annotation created in the domain. And then we can, from the outside, use AOP or advices to add transaction on every method, for example. You can even play around with naming conventions to know if it's a read-only transaction, etc. So we try from the outside to map technologies on your code using stereotypes. And if you work with DDD, then you have all the tactical patterns like repository, domain service, aggregate, etc. Then for the security, what we usually do is authentication is a technical thing again, because it's not relevant to the domain if you use OAuth, SAML, basic authentication. And then we separate the authorization in two levels. We have, of course, security on the data level, and this is something you have to do in the domain. But most of the time, these are requirements from the business. Let's say a user is only allowed to see tasks that are assigned to himself. That's a business requirement and can be expressed directly in the code. So it's really clear what's the purpose. And the more higher level roles can be directly set on the infrastructure layer. And again, if the domain needs to know which user is doing what, then you can use the same pattern as for the repository. You have just an interface that gives back the actual user, and the implementation where this user is coming from is in the infrastructure layer. I have to hurry up a little bit. Then what's really interesting is when you have this onion and all these stereotypes, you can also start to check that your architecture is respected throughout the code in an automated way. And that's really something important as an architect, because you don't want to spend 2-3 hours a day reviewing pull requests and finding out illegal dependencies between packages or between layers. And JQ Assistant is a tool, a Maven plugin that parses the whole code and writes that down in a Neo4j database. So you have a graph over your whole code. You can say, give me all classes annotated with this annotation, or give me all classes that have a dependency on this other class. You can really find everything you want in your code. And then once this code is parsed, we can write queries to check violations. So the idea is to say, for example, an application service is never allowed to return an aggregate root. And then you could write a query that checks if there is any application services that does that. And if one or more result is coming back, then your build is breaking. So you don't have to check that by hand. It's just done on every build. And what's really, really nice with JQ Assistant is that you can define these rules in an ASCII document. So as an architect, you can say, okay, these are the concepts in my application. I have application services, I have aggregate roots. You can write some text to this concept to describe what's this concept. And a piece of Neo4j query that will actually represent this concept on the database. And then there is another part where you can define the constraint. So for example, this constraint, I told you before, an application service is not allowed to return aggregate roots. You can define a query that makes sure that this never happens, but you can also have some text that explains why you want this to be respected. So here I have wrote a concept. So I say I want all the Java types in my application that have a Java annotation of type application service. I set that in Neo4j, you can define so-called labels. And once this code is run, then I can always refer to this concept just by saying application service. I don't have to rewrite that. And then I can define a constraint. So I say, give me all the application service. Give me all the methods of the application services that return an aggregate root. And I define another concept, what's an aggregate root. And I'm only interested in public methods. And I just return all these methods that return an aggregate root. And if one guy in my development team is returning an aggregate root in his application service, he would get an error in the build. And he would also get the text that belongs to this error. So he sees, oh, I broke something, and he can read why he broke it and why it's necessary to enforce that. So thanks. I know it's very, very short. I could have going deeper in every subject here. If someone wants more details, you can just come by the Mimacom booth. I'm really happy to show you. I can also show you live how you can query your code. And I think, have I time for questions or? No, right? Okay, so then have a nice lunch. Thank you for listening.